it is at minus 15. Right? And then we know that it'll be sliding down this way, right? So when it's sliding down that way, the other plane will have the shear in that orientation. Okay, so we are given that it is 5 ksi. Okay, so now what do we know? Okay, so we know that stress x beta, not we know, we don't know what is this number. We did not measure. We don't know. Now question, can any one of you, will any one of you say that it is 0? Yes or no? Because I did not draw anything, right? There's a possibility it's 0. But I'm going to tell you now, stress x beta cannot be equal to 0. Okay, I'll write down here. Cannot be equal to 0 over here. Okay. Later on, we will see why. Okay. Now we know stress y beta. Stress y beta is minus 15 ksi. Right. Then we also know that stress y beta, the shear stress y beta, is equal to the shear stress x beta, and it's positive shear, so it's plus by 5 ksi. Okay, so that's all we know now. Now, so this is a very interesting problem. Okay, so I'm going to call this point x beta. Right, we're going to call this point y beta. Right, so we have x beta and y beta. So we have two elements, right? And we do know the position of 2 points. Okay, so one point is at point x, point y. Okay, where I just stick, and the other one is at y beta. The issue with this problem is this: when we did other problems, we know 2 points on the element, but it's on a single what element, right? Now we know 2 points, but each point is attached to each element. So it's very different now. Okay. So before I can explain in deeper context what is the difference, let's start constructing Mohs circle and see what will happen first. Okay, let's start constructing Mohs circle. So we're going to construct Mohs circle first. Okay. So I'm going to have we're going to construct Mohs circle. Okay, so it's going to be 25. No, it's not 25. So this problem is, okay, so will be minus 22 minus 20, 18, 16, 14, 12, 10, 8, 6, 4, 2, 0, and 2. Okay, so these are x-axis, our normal stress axis. Then we have our shearing stress axis. Okay, so that's our shearing stress. So our shearing stress, element rotate clockwise at the top, element rotate anti-clockwise at the bottom. So we have 2, 4, 6, 8, 10. Okay, so whatever scale you use on the top, you have to also use the same at the bottom. So minus 2, sorry, on the horizontal axis and on the vertical axis, the scale have to be the same. Or not, it's not Mohs circle, it's going to be Mohs over. Okay, minus 10. then element rotate anti-clockwise. Okay, so now let's get 2 points. Okay, so we know, right? So let me zoom out for you guys. Okay, so I want you all to see what I'm doing together with the elements. Okay, you can see now. Okay, if I could squeeze in the elements, yeah, I'll do this way. So what you can see now, let's look at point X. Okay, point, not X beta. Okay, so let's look at point X. So point X has 0 normal stress and 0 shear stress. So on the element or on mole circle over here, this is my point what? My point X. And that's all I can plot. I cannot plot point Y because I don't know what is P over A on point Y, right? Then on the beta orientated element, we know where Y beta is. Okay, so Y beta is on minus 15 line. Okay, so I'm going to draw minus 15 line. Okay, so this is our minus 15 line, right? So this is our stress Y beta. And then we also know that it's running horizontal. Okay, it's running horizontal at what? 5. Okay, so this is our fine line, the shear. Okay, and then at the bottom bit is our minus 5. Okay, so from here we want to see whether Y beta is at the top or bottom. So if you look at this element, the beta orientated element, the one on your right hand side, the 5 which I'm highlighting now, okay, and it's Y beta, is generating an element rotation in the clockwise direction, right? So now we know over here is our Y beta point. Okay, our Y beta point. That's all we know. We don't know what is P over A. We don't know where point Y is, right? We don't know where point Y is. We don't know where point Y is. I got it wrong, okay? So X we know. Point Y, we have not a clue, okay? Because what is P over A? Right, I don't know what is P over A. What do you mean P over A? We don't know what is P over A. So when that's the case, right, we are going to find what is point Y, okay? Now, what you see is that we have 2 points, right? We have 2 points, okay? And the 2 points is not the same like from a single element. Now we have 2 elements. Each element has each point. What we have used to be doing, like on the previous example, we have 1 element and we have 2 known stresses. Okay, so I mean by 2 known points. Over here now, you have 2 elements and you have X known point belongs to 0 degrees orientation element, and then you have Y beta on a beta oriented element. So what is the difference is this, okay? Y beta and X, if you look at Y beta and X, right? If we were to look at Y beta and X now, right? They are, so X is at 0, Y beta is in the upper, above the what? The 0 axis or on normal stress axis, okay? When everything was on the same element, right? You can see point Y is here. Point X is below the what? Below the horizontal axis, normal stress axis or 0 shearing stress axis. Okay. But for our case now, what you see is point X, Y beta is here. Point X did not cross the what? It's not somewhere below the shear stress, which is equal to 0. Okay. So now, how do we solve a problem like this? Okay. So remember, we have done this before. Okay. When we started, right? When we started, what do we do? When we started, we talk about when we started, we talk about the what? Right? Rules of the circle. Right? We mentioned rules of the circle. You can solve the problem using simultaneous equation, but we're not going to do that. We're going to look at the rules of the circle. So the rules of the circle, let me quickly have you recall. Right? So this is what 6, 3, 6. So remember, I got you guys to draw a circle, right? We found a center point, right? Then we drew a what? We drew a line from here to here. That's what I mean by rules of the circle, right? Right? So the next thing that we're going to do is we're going to pick a point, right? So this is point A, point B, and this is point C, and the center of a circle is point 0. And point C is a point that we pick anytime. Then when we join point A to point C, right? Point C to point B, right? We know this is equal to what? 90 degrees, right? So we're going to use the rules of the circle to solve this problem, okay? So coming back to the mole circle now, right? We come back to the mole circle. We're going to draw x to y beta, right? So that's x to y beta. And then I'm going to take that point or that line. I'm going to take that point line. I'm going to copy. I'm going to paste. And then I'm going to rotate it by 90 degrees. Right? So this is my 90 degrees rotation. So over here, now over here, this will be my y point. Because this has to be what? 90 degrees, yes or no? Right? Y over there, that is my y point. It's simple. I'll explain to you why. Okay, so this is my, let me beautify this first. Okay. So why that is the case? Because point X to point Y, the rotation has to be what? 180 degrees from the center of the circle. Yes or no? Why? Because of the element point X and point Y, the angle made over here is what? 90 degrees. Oh, sorry. Right? So point Y, as you can see over here, right? That I'm highlighting point X to point Y, the angle made over here is what? 90 degrees on the element. That's why on mole circle, right? If you look at mole circle now, point X and point Y will lie on the straight line. Okay, because once we have identified the center of the circle, right? So center of circle, I'm just going to eyeball this. Okay, so if this is the center of circle, there's our point O, right? And the rotation from point X to point Y from the center of circle is 180 degrees. That's why point Y is on the what? Zero shear line. Okay. So now we have to calculate what? We have to calculate where point Y is. Why we have to calculate where point Y is, then we can calculate the average of the circle. Okay. So we know this. So we are going to calculate this angle over here. This angle over here, I'm going to call alpha. Okay. So if that angle over there is alpha, this angle over here is also equal to alpha, similar triangles. Okay. So there are two values that we know. There are two values that we know. So one value is this axis over here. We know this axis. Right. So from here to here is what? 5. Right. And then we also know on the horizontal, this is what? This is 15. Right. So we can work this out. So we can say tangent alpha is equal to 5 divided by 15. Alpha is equal to 5 divided by 15 inverse tangent is equal to 18.43 degrees. Right? So we know that's 18.43 degrees. So this angle over here is also 18.4. Right? So we now can find stress Y